Let's talk about neural networks with Keras. Neural networks learn by training. They consider examples generally without being programmed with task-specific rules. There are three main parts: an input layer, a hidden layer, and an output layer. The input layer inputs information to process, the hidden layer contains nodes that process the information, and the output layer collects information and provides an output. The input layer collects information for the neural network to process. Each node represents some feature or information. The hidden layer are nodes that receive information from the previous layer's nodes, multiply by a weight, and then add a bias term. The activation function normalizes the data from the hidden layer by providing a weighted sum of the inputs and serves as an input to the output layer. The output layer just simply brings together the information from the last hidden layer of the network to output all the information you need in order to make a prediction. These models are improved by using something called backpropagation, or backprop for short. Backprop is an application of the chain rule used to update the weights and optimize the algorithm. So again, backpropagation is an application of the chain rule, and it's used to derive the model error with respect to the weights and optimize the weights and build a better model. This process is called gradient descent. The feed-forward process assesses the model error by evaluating the actual values versus the predicted values, or y minus y hat. Backpropagation runs the feed-forward operation in reverse, basically. And the goal is to find the lowest gradient, or to derive the best model with respect to the weights, update those weights, reduce the error, and continue to refine the model. Convolutional neural networks. So convolutional neural networks are great at determining objects inside of images. What's inside of an image? Is it a cat? Is it a dog? Is it a bird? Or perhaps a sunset? These are things that are typically classified using convolutional neural networks, and they're very good at determining what is inside of an image. So the structure is a little bit different with a convolutional neural network. It contains an input of a multi-channeled image. You have a number of different hidden layers, pooling layers, and fully connected and normalization layers. And all these layers work together in order to determine a classification of the object inside the image. Is it a bird? Is it a sunset? Is it a dog or a cat? And we'll talk a little bit more about how it does that in 1 second. So with generative adversarial networks, it's a powerful class of neural networks that are used for unsupervised learning. It was introduced in 2014 by Ian Goodfellow, and GANs are basically made up of a system of two neural network models which compete with each other and are able to capture and copy the variations within a data set. So GANs are typically used in order to generate images that have never been seen before. For example, if you're looking at this particular painting on the left, that was created using a GAN. So GANs are very good at creating images that have never been seen before. And essentially what you are doing is you have two neural networks. One neural network that is a generator and another neural network that is called a discriminator. So the generator generates images that have never been seen before, and it presents those images to the discriminator. The discriminator continues to say, no, this doesn't cut the mustard, this isn't going to pass, this is not a correct image, this is not a real image, until eventually the generator generates images that are able to fool the discriminator. And when that happens, you're able to have images that have never been seen before and are able to pass as real images. Recurrent neural networks. Okay, we're going to take a very quick break, and we're going to come right back and talk about recurrent neural networks.